The technician should be able to discuss the name, styles, classification, and safe use of open-end, box-end, and combination wrenches. Open-end, box-end, and combination wrenches are used very often by technicians working on vehicles. The open-end wrench's name is derived from the openings at each end of the wrench. Open-end wrenches are sized by the distance across the opening of the flats of the wrench and has two different sizes on each wrench. Open-end wrenches are available in both fractional and metric sizes. Here you can see one wrench is a fractional size expressed in fractions of an inch, and one end is metric sized expressed in millimeters. Open wrenches have a 15-degree offset on each opening. This allows better alignment access when working in tight areas. If the wrench cannot be aligned or turned completely, turn the wrench over and retry. The open-end wrench can be fitted to a fastener very quickly, but has the disadvantage of easily slipping off when force is applied, because the fastener is gripped by only two flats of the hex head. The box-end wrench also has two different opening sizes, but has the advantage of gripping the fastener head much more securely than the open end. Box-end wrenches are available in both fractional and metric sizes, as well as having both 6-point and 12-point openings. Box-end wrenches provide superior fastener gripping force without slippage. Box-end wrenches also have a 15-degree offset that allows clearance for your fingers when using the wrench on fasteners. 12-point box-end openings allow quick alignment of the wrench to the fastener, whereas 6-point openings provide the best grip of the fastener with minimal potential for slipping when used on worn or rusted bolt or nut heads. Combination wrenches combine the features of both an open-end and a box-end wrench. Combination wrenches have the same size at each end of the wrench. Combination wrenches are available in both fractional and metric sizes, as well as having both 6-point and 12-point openings on the box end of the wrench. To properly use a combination wrench, use box end first to initially break loose the fastener, then switch to the open end for speed in removing the fastener. Combination wrenches are the most common style of wrench used by technicians. Combination wrenches are available in 3 different lengths. The standard length is used for general repair. Combination wrenches are available in short pattern lengths, which provide better access in tight work areas. Short combination wrenches are available in both fractional and metric sizes. Combination wrenches are available in long pattern lengths, which provide additional leverage and reach for specific working conditions. It is common to use 2 wrenches together to loosen many types of tubing and line fittings on the vehicle. Open-end, box-end, and combination wrenches are often purchased in sets covering a wide range of opening sizes. It's important for the technician to understand the proper and safe use of wrenches.
Plug-style tap, that's the most common and one you'll most likely be using. Next to it is a national pipe thread tap, and that's very common, but there's a couple of tricks to using them. And finally is a standard die, and we're going to look at using all of these. These dies are identical, except the one on the left has the bottom side facing up. You can see the cutting threads taper out to nothing on the left, and on the right is the full cutting threads at the top. This die set only has writing on the bottom surface, so when we install it into the holder, we want that bottom surface facing out. The plug style tap that we're going to be using has a tapered end that helps get you started in a hole. When deciding on the depth of the hole, it's important to remember that that taper means that you're not going to get threads all the way to the bottom of the hole. Most threaded holes are like this. That little extra space at the bottom of the hole is a good place for debris or scale to fall without interfering with the bolt. You can see here how the tapered part of the tap relates to that unthreaded portion of the hole. When used with the proper size hole, that taper on the tap helps you get it started straight. You really want to focus on keeping the tap straight to the hole the first few turns. When a tap actually starts cutting threads, it'll want to stay straight all on its own. A little bit of oil on the tap will help it cut cleanly and help it keep the chips free. When the tap starts cutting threads, you want to make sure that you go about a half to 1 full turn and then back it up a quarter to a half a turn to break the chips. Then you can turn the tap back in where it starts cutting threads again and go another half to full turn before repeating the process. I like this ratcheting tap handle from my KB tap and die set. That ratcheting action makes it easier to keep the tap straight because you don't have to go hand over hand. And once the tap's well established in a hole, you can spin it easier like you would a regular handle. The directional lever for the ratchet makes it easy to back up to break up the chips and then flip it back into forward and run it back down where you're cutting threads again. After you've cut all the threads, remove the tap and clean up the flutes to get rid of all the chips that are in there. And then I'll add a little oil and run the tap over the threads a couple of times just to make sure they're all good and clean. Then we can screw the piece in that the hole's designed for and see how we did. Using a die is very much the same. Make sure that you get it started square whether you're making new threads or cleaning up old threads like we're doing here. As we did with the tap, you want to make sure you back up every now and then to break up the chips. I also like to go back and run the die up and down the threads a couple of times just to make sure they're all clean. This is a national pipe thread tap, and all the procedures are the same except that we stop threading with several of the threads above the hole. That's because this tap is tapered over its full length, and that's there for a reason. When threading in a piece of pipe or a plug, you want it to stop before it passes through the hole. This helps seal it up. I usually stop tapping with 6 or 8 threads showing and then try the plug.
This is a vise, and this is a piece of metal, and it's on the thick side. What I'm going to demonstrate today is how to drill holes in metal. Now, I've already done 2 holes. Now I'm going to do a 3rd one, and I'm going to show you just how easy it is. So here's the thing. You have a few options when it comes to drill bits, but I recommend that you purchase a drill bit coated with titanium aluminum nitrate. Now, how can you tell? Well, these drill bits have kind of a golden color to them. That's how you know. So here's the thing that makes these drill bits really terrific for drilling or boring through metal, and that is they're hard and they're tough and have a low coefficient of friction. Now, what that means to us is you don't have to use a lubricant most times. There's some metals you want to use lubricants for, but you don't have to. So now what this tool here is it's called a center punch, and we're going to use this center punch to mark our metal. Let me show you how that's done. Okay, so I've got my center punch where I want it. Now what I'm going to do is I'm just going to tap it with a hammer. Let me tap it one more time. And what we've got is we got a little bit of a dimple there. Do you see that? Well, what that's going to do is it's going to keep our drill bit on track. If we didn't have that dimple there, it would be skirting all over the metal. We don't want that. So that little dimple is going to keep it in place. Now what I'm going to do is I'm just going to put a little dab of lubricant here. Now remember what I said, with a titanium bit you don't have to use oil. It's optional. I'm choosing to use oil because the metal is a little bit on the thick side. Okay, so I've got my drill in place. The trick is to just take your time. We're not trying to win a race. We're going to just apply a small amount of pressure to the drill, and we're going to take it easy, take it slow. Clean this off a little bit. Let me just brush off the shavings. I'm going to take it out of the vise so you can take a good look at it here. First of all, look at the thickness of the metal. I'm going to flip it over to the other side. Folks, that's all it takes to drill through